Okay, solving inequalities with a sign table again. When we get one of these, we want to make sure that it's some inequality involving 0, and indeed it is, so good. We want to try to factor this if we can, and about the only factoring that we could do that isn't done already is we could factor a 2 out of the denominator. So we have x minus 4 over 2x plus 3. There we are, completely factored. Okay, now we go looking for what we call critical values, which is places where this expression either equals 0 or is undefined. And there are 2 of them. From the x minus 4, we get that this expression would be 0 if x equaled 4. The other point is, if x were negative 3, our denominator would be 0, which would make this entire thing undefined. So, 2 critical values to worry about, negative 3 and 4. What do we do with those? We make a number line. We put them on it in number line order, so low to high, and we're going to look exactly on those critical numbers and see how our expression behaves. We're also going to look between those critical numbers, see what happens there. Now, the factors we have to look at are x minus 4. Technically we have 2. We often skip factors like 2, and you'll see why in a minute, but I'll put it in. It's fine to put it in the list. And we have x plus 3 as one of our factors. So we'll do all of those independently. And at the bottom, we will have another row where we do the combined function, the x minus 4 over 2x plus 3. I'm writing the factored version because it's a little easier to work with. So here we're looking at numbers below minus 3, exactly on minus 3, between minus 3 and 4, so 0 or something like that, exactly on 4, and then any number bigger than 4 for x. If x is lower than minus 3 and then you subtract 4 from it, you definitely get a negative value. If you have negative 3 and you subtract negative 4, you get negative 7. If you have 0 or something in that neighborhood and you subtract 4 from it, you get negative again. 4 minus 4 comes out to 0, and more than 4 minus 4 comes out positive. 2 is a fixed number. It's positive all the time. The reason we skip numbers like this usually is that because they're always positive, they don't have any effect on the sign of the rest of the expression. So I could absolutely have left this out, and in future examples I probably will, but I wanted to show you that if you put it in the table, it's okay. You will get the right answer doing this. Later on, if I leave out a 2 or some other positive coefficient, it's because multiplying by a positive doesn't do anything to change the sign of an expression, so writing them out is kind of a waste of ink. For the x plus 3, let's see, if x is lower than negative 3, so if it's minus 5 or something, we get minus 5 plus 3 comes out negative. If we're exactly on negative 3, we get negative 3 plus 3 is 0. If we have, like 0 plus 3, positive. 4 plus 3, positive. Bigger than 4 plus 3, definitely positive. Okay, so there's all our pieces. Now, what happens when we do this number divided by this number and also divided by this number? For this first one, we get negative over positive times negative, which is negative over negative, which is positive. Is that greater than 0, like we were asking for? Yes. So this section where we're lower than minus 3 is part of our solution. If we're right on negative 3, we get a negative number over a positive number times 0. Negative number divided by 0 is undefined, which means no. You're never part of a solution if you're undefined. That means you don't even know what the value of your function is, so you certainly can't say it's greater than or less than 0. So that section is out. If we're between minus 3 and 4, we get negative over positive times positive. That's negative overall. Is negative greater than 0? Nope, that's not part of our solution either. Here we get 0 over a positive times another positive, which is 0. Is 0 greater than 0? Nope, that's not in our solution space either. And for the last part, we get a positive value over a positive times another positive. Overall, the expression's positive there. If it's positive, is it greater than 0? Yeah, it is. So we get solution in two different places here. We get solution when we're lower than negative 3 or when we're higher than 4. You could write that in interval notation if you wanted and say x can be less than negative 3 or x can be greater than 4. Or if you like bracket notation, and who doesn't, you can say x can be anything from minus infinity up to minus 3, and also anything from 4 up to plus infinity.